UK, USA, and other English-speaking countries, yes? And now we will find out more information about Halloween traditions from around the world, and I have brought an extra video for you. You will watch and you will enjoy it. I guess it's very interesting, and you will find out different kind of traditions, customs, and beliefs in different countries. Let's start if you are ready. Okay, now you have enough information. Who can tell the Halloween? Did you watch?
Yes.
Why are you silent? Okay, tell me about Halloween holiday in England or in USA.
Hello, it's a holiday when people wear costumes and masks.
And
And children go people's door and ask. They ask money,
money or candies, yes?
candy. Yes.
Okay, and what else? Another person who can answer. They wear different costumes, yes? And
Yes.
all countries have their own beliefs and their different traditions in this day. So you have now enough information, and I will forward this video to the Telegram group, and you will watch it one more time, and then you will discuss with your group mates, okay?
Yes.
Now we will talk about natural disasters. It is our today's topic. We will discuss some factors and some reasons for natural disasters today. So let's start with first slide, natural disasters. It is Earth's energy sources and systems, Earth's internal structure and introduction to plate tectonics. Now you can see in this slide Earth systems. First, solar energy, it is sun, you know, and precipitation at atmosphere and hydrosphere, weather and climate and evaporation, and you can see there are ocean circulation, and it is green, and it's biosphere, which is considered photosynthesis and flow of water and nutrients. And it is lithosphere, and it is brown, and you can see there are mountains, and it is called a rock cycle. And it is considered rocks which are altered by weather. And you can see rising magma. It is hot. It is very hot, and it is the bottom of the earth. Can you see the screen? Can you see the screen clearly? Is it visible for everyone?
Yes.
Okay. Let's move to the consequences of a dynamic earth. You can see it is earthquakes, volcanoes, and mountain buildings. All of them are natural disasters. So there are energy sources for natural disasters. The first one is gravity. What is gravity itself? So you can see there is written some statement about gravity. First, the planet Earth generates a pull on every other object in the entire universe. It is this pull that creates weight. It is this pull that causes an object to fall. Such a pull is called a force. So this pull is called a force. And the force that causes an object to fail is the force due to gravity. Gravity on the Earth is constant. All objects fall equally fast, and if we think about this and take it a bit further, we come to the realization that the force of gravity is what causes the acceleration due to gravity, the gravitational acceleration of the Earth. And so, gravity and Newton's law, F. So you can see there are Newton's law and gravity. A force applied to an object causes an acceleration in that object, and the force of gravity is what causes the acceleration due to gravity. And next one, the more material an object has, or the greater its mass, the greater the force that pulls on it. I guess all of you know Newton's law from the physics at school. The net force acting on an object is equal to the product of the object's mass and its acceleration. Consider free fall of an object due to gravity. The force of gravity is proportional to mass m, so we can write F equivalent mg, whereas g is the acceleration of gravity directed downwards. So, energy sources for natural disasters. Gravity and Earth's internal heat are considered energy sources for natural disasters. So, can you see the screen now?
Yes.
But I have unstable internet connection. Internal sources of energy. There are three sources of the Earth's internal energy, or we can say it is heat. First, the impacts of asteroids and the decay of radioactive elements and gravitational contraction. You can see the impact of asteroids, and decay of radioactive elements, This is, and gravitational contraction, it is called gravitational contraction, it is outer circle. So next one is the origin of the solar system. You can see there are different pictures. They are four pictures, and first one, rotating cloud of dust and gas gathers due to gravitational forces, and then rotating mass contracts and flattens with most of the mass in the center, and star ignites to form the sun. Then gases belong to outer planets. So planets formed by the accretion of stony and iron meteorites as well as ice particles. Then you can see there are planets. Can you hear me now? Is it visible? Guys,
Yes,
Yes.
but I can't hear you. So let's continue. So you can see there are inner planets and outer planets. Venus, Mars, Mercury, Earth. It is inner planets of the Sun, and outer planets, Jupiter, Saturn, Uranus, Neptune, Pluto, they are considered outer planets of the Sun. So it is early Earth is hot, hot, hot. You know, hot sources. They are gravitational collapse, impact energy, and radioactive decay. So you can see there are internal heat engine, and they are hot rock rises, cold rock sinks, and rock cools. They circle ocean floor, and rock cools and can you hear me now?
yes.
So the energy source for natural disasters we discussed, they are gravity, Earth's internal heat, and solar energy. And then it is solar energy flow. We can see it is the sun, and it reflects short wavelength radiation and long waves radiation. It is the types of reflections, and you can see there are two types of radiation: long wavelength radiation and short wavelengths of radiation. And in the next slide, hydrologic cycle. What is hydrologic cycle? It is water from streams and groundwater flows to the sea. You can see there are rain, transpiration, and sunlight and evaporation from lakes, streams, and soils. First sunlight and sea, then it rains, and all this water will be transported into the air. So there will be evaporation from lakes, streams, and soil. Next one is uneven distribution of solar energy causes severe weather. So you can see different pictures here. It is the uneven distribution of solar energy, and it's the severe weather. Natural disasters, we talked about this one, and you can see there are chemical differentiation of the earth. We can skip this part, and it is differentiation. First one called crust, and next one called mantle, and last one core. So it produces Earth's internal structure. It is surface, it is inner circle, it is the inner of the Earth. You can see it is egg, like the shape of egg. So this is called crust. Next one, solid iron inner core, and this one called is liquid iron outer core, and it is called mantle. All of these steps, all of these phases you learned from the astronomy, yes, at school. And it is Earth structure. The Earth today is the product of over 4.5 billion years of differentiation into layers of varying density. The 8 most abundant elements in the Earth are iron, oxygen, silicon, magnesium, sodium, calcium, aluminum, and potassium. You can see there are all different phases of the Earth. First, crust, atmosphere, lithosphere, mesosphere, and temperature and pressure increase with depth at the bottom. And it is called continental crust, thickness greatly exaggerated in this peak. So, it is Earth structure, density, stratified layers. Earth's core. What is Earth's core? The Earth's core is composed of two parts, the inner core and the outer core. The inner core is solid iron and nickel, and the outer core is liquid Fe and Ni. So Earth structure, density, stratified layers, it is mantle. Chemically, the mantle is composed of Fe and Mg, Ca, and O. Ultramafic. It is running time. Okay, you can see the mantle extends from roughly 50 and 2,900 kilometers below the Earth's surface. And next one, Earth structure, density, stratified layers, its crust. Crust is composed of two types, oceanic crust and continental crust. So next one is Earth structure, density, stratified layers. So they are crust versus mantle. Earth structure. Earth is layers of different strengths. So you can see the picture and the layers of different strengths, and we define the Earth, define with this picture and with this definition. The Earth is layered with respect to physical properties. The crust and the upper part of the mantle is called lithosphere, and it's rigid, brittle, and behaves elastically. The part of the mantle directly below the lithosphere is termed the asthenosphere, which behaves like a plastic, a solid that flows. So upper mantle and crustal structure. Next one is natural disasters. We discussed this part, and plate tectonic theory. It's the last part of the lesson. There are 6 large plates: Pacific plate and Eurasian plate, African plate, South American plate, Eurasian plate, and North American plate and Caribbean plate. And small plates, you can see Arabian plate and others. And mantle convection drives plate motion. It's the heat sources. Heat sources, original heat from formation of the Earth, and radioactive decay of the U, Z, and K in the core and mantle. We can skip this part, and you can see types of plate boundaries. They are divergent, transform, convergent. And next one, divergent boundary. They are Iceland and Mid-Atlantic Ridge. And next one, transform boundary. You can see there are lithospheric age increases with distance from ridge, and ridge, rift, scarp, transform, lithosphere, asthenosphere, and rising magma. Next one is transform boundary, San Andreas Fault, CA, Pacific Plate and North American Plate. And this is convergent boundary. They are Tibetan Plateau, Himalaya Mountains, and Southern Eastern Asia. Convergent boundary, Andes Mountains and South America. So it's the last, and you can see there are divergent boundary seafloor spreading, convergent boundary plates subduction. So how volcanism appears? It's the cause of magma forming. You can see mountain building here and magma forming, and it is volcanism. And your assignment is located on Moodle platform.